let's run through a problem where we're going to have to do a definite integral, but we're going to need to use integration by parts. So as we get looking at this, you'll notice it looks a little bit complicated, but don't worry, we'll walk through every single step of the way. Let's go ahead and first try to pick out our u and our dv. So our u, typically if we have a natural log involved like we do on this one, it's going to be the natural log part. So the natural log of 3x. So that part goes as our u. Next, let's pick out the dv. Has to be everything else involved in here. So we have the x to the fourth and the dx. That's going to go as our dv. Now, one of the challenges with integration by parts is picking everything out, the appropriate thing, our u and our dv, but then we also need to go ahead and both take a derivative and integrate at kind of the same time. So let's make these two separate steps. First of all, we have the u equals natural log of 3x. This is the part that we need to take the derivative of. So on the left-hand side, we're going to get a du. On the right-hand side, we're going to use the chain rule to take the derivative of natural log of 3x. We have an inner function, the 3x, and an outer function, the natural log. So first we deal with the outer function, the natural log. Its derivative is 1 over, and then whatever's on the inside, the 3x. But we also need to multiply by the derivative of the inner function. So the inner function, 3x, its derivative is going to be 3. Then we also include a dx with this because we're taking the derivative. Now we can simplify this part a little bit, right? We're multiplying by 3 and dividing by 3, so this actually works out to be 1 over x dx. All right, so that was the taking the derivative part. Next, we have to integrate the dv equals x to the fourth dx. So when we integrate, we're going to get v on the left-hand side, and we're going to use the power rule on the right-hand side. So the power rule says we're going to increase the exponent by 1, so 4 becomes a 5, and then divide by our new exponent. Now I tend to write these as 1 over whatever our new exponent is. Multiplying by 1/5 is the same thing as dividing by 5. So either way you write it should be worked out okay. All right, so now we've got all our information over here. Let's go ahead and fill into our formula. So this is going to equal, when we plug in first, let's go ahead and plug in our u is the natural log of 3x. Then our v is going to be 1/5, and I'll go ahead and put the x to the 5th at the end. Personal preference, I always like to keep my constants out in front. This will still be integrated with the bounds of integration being 2 and 7, then minus the integral from, again, 2 to 7, same as the original bounds of integration. We're going to fill in our v, which is 1/5 x to the 5th power. Again, I like kind of moving the constants out in front, but you can see where they're going there. And finally, our du. Our du in this case, as you can see on the left-hand side, is equal to 1 over x dx after we simplified it down. All right, at this point, we have all the information there. We still need to do a little bit of filling in our bounds of integration, subtracting, and that sort of thing. So let's walk through the next steps. I'm going to kind of ignore what's out in front here for the time being and just leave it as 1/5 natural log of 3x times x to the 5th between 2 and 7. We'll come back to that. But on the inside here, let's go ahead and bring along our 1/5. Let's simplify what's on the inside before we work on doing any integrating. All right, so we have x to the 5th in the numerator, and we have x to the 1st in the denominator, so a little subtracting should get us x to the 4th power overall on the inside there. All right, next, let's go ahead, just bring along the first part, natural log of 3x, x to the 5th, from 2 to 7. I am going to fill in those bounds of integration in a second, but let's do our integrating first with this last part. So the 1/5 comes along. We're going to use the power rule here. where we increase the exponent by 1, so 4 becomes a 5, and then we want to divide by that new exponent. Again, I like writing this as multiplying by 1 over 5. Evaluated between 2 and 7. All right, at this point, I think it's a very good place to start filling in all of our values. All right, so at the beginning here, we have our 1/5 natural log of 3 times the upper bound 7 times 7 to the 5th power. So that's replacing each of the x's with our upper bound, the 7, minus 1/5 natural log of 3 times the lower bound 2 times 2 to the 5th power. So that's the first half there. Next, let's go ahead and say we're going to subtract 1/25, and then let's fill in the x to the 5th power. So I'm kind of treating this as the 1/5 times 1/5 gives us the 1/25. Now I'm going to just evaluate the x to the 5th power with the bounds of integration. So I'm going to say 7 to the 5th power minus 2 to the 5th power. You could have put the 1/25 with each one, but I'm going to distribute in a second. All right, what simplifying down can we do? Well, it's going to be 1/5 natural log of 3 times 7 makes 21. Did that part in my head. But what about the multiplied by 7 to the 5th power? Did not do this part in my head. I got 16,807 minus 1/5 natural log of 3 times 2 makes 6, and then 2 to the 5th power works out to be multiplied by 32. Okay, minus, I'm going to keep the 1/25 on the outside for the time being, and again we get 7 to the 5th, comes up again. All right, well that was that same computation, 16,807 minus 32, 2 to the 5th. Let's continue simplifying as we go here. I'm going to think of this as being over 1, so it's going to go up in my numerator, right? I'm going to multiply that by that 1/5 in front, so 16,807 over 5 times natural log of 21. You could put that part in the numerator as well if you want. Again, I'm thinking 32 over 1. It's going to get combined with that 1/5 in front, so 32 over 5. Natural log of 6 minus, I'm going to go ahead and combine what's inside of our parentheses first. As we go ahead and combine those together, I guess we get 16,775. So in this example, that happens to be a multiple of 25, right? It ends with a 75. So we can simplify just a little bit more. All the first part comes along. This is going to be the exact same. This is going to be the exact same. But this last computation is going to be minus 671. Hopefully that makes sense. I'm not going to copy that back down and spend any more time writing here. So as you get going here, take your time, try to identify exactly what each component is from the beginning. Right? If you have a natural log involved, try to make that the u component. Then everything else involved with that integral, it's going to be the dv. All right, and then fill in, take our derivative, take our antiderivative, fill into the formula, and take your time as you go the rest of the way. Anyway, I hope this helps. Best of luck as you're working integration by parts. It takes practice, but you can get there.